plus I naught. Plot Vx and Vy as a function of time for the circuits illustrated in figure 10.64. Assume I naught is constant. Now let's calculate Vx right here. Voltage X is going to be just, if you apply KVL, this is going to be just VCC minus the current going through this one, that is I1 minus IT, because IT is going in the other way. IT is exiting, I1 is entering. So I1 minus IT times RC. Okay, this is Vx, actually Vx. Now instead of I1 we are going to plug this one, the one that given, I naught cos omega t plus I naught. So this will become VCC minus I naught cos omega t plus I naught minus IT times RC. Okay, so this is for Vx. And also we can simplify this one further, or we can just take this IT outside and multiply like this. Okay, now let's calculate Vy. If you look at Vy, IT is entering and I2 also in the same direction. So this is going to be just VCC minus I2 plus IT times RC. So VCC minus I2 is negative I naught cos omega t plus I naught, negative I naught cos omega t plus I naught plus IT cos omega t times plus I naught plus IT times RC. Now if we take I naught common, this will become VCC minus, if I take I naught common, this is going to be just 1 minus cos omega t plus IT times RC. This is Vy. Now let's go ahead and draw the graph. VCC minus 2 I naught plus IT times RC, and here we will have VCC minus I naught plus IT times RC, and here we have VCC minus 2 I naught minus IT times RC, and here we will have VCC minus IT times RC, and then VCC minus I naught minus IT times RC, and above we will have VCC plus IT times RC. Now the graph is going to look like this. We will have dot dot dot, let's put this dot 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 for Vy and straight line for Vx. The dot 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 line goes like this. It's going to, this is negative phi over omega, and this one is positive phi over omega. Let's use a different color. Dot 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 line, the Y line go minimum VCC minus 2 I naught times plus IT times RC, and then the maximum is going to be VCC minus IT times RC, and then it goes like this. This is for Vy. Now let's look at the Vx. Vx will go like this. The maximum is going to be VCC IT RC. It's a little bit above, then it passes through this VCC minus 2 I naught minus IT times RC, and then again goes like this, like this. This is the graph for Vy and Vx, and from this graph you can see both of them, Vx and Vy, are in the opposite direction, and Vx is maximum when it is VCC plus IT times RC, and the minimum value is VCC minus 2I0 minus IT RC for Vx. Now let's look at for Vy. Vy, the maximum is VCC minus IT times VCC minus IT times RC, and the minimum value of Vy is VCC minus 2I0 plus IT times RC. And that's the graph for Vx and Vy for this given circuit. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics too, there are bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.